Welcome to lesson 2.3, rate of change in slope. So you might have heard of this already, but in Algebra 1, but rate of change, that's literally saying the same thing as slope. It's the steepness of the line. It's your vertical change, so your change in f of x and y, over a change of x. So it is your rise over your run, y2 minus y1 over x2 minus x1. So it's called slope. And all of these are valid, but I highlighted the ones that we'll use the most often. So right here, for instance, this guy is talking about the rise over the run, so we can count. So we have a horizontal run of 1, 2, 3, 4. Right, horizontal is on the bottom, over a vertical rise of 2. So the slope is 1/2. If I go up 1, I go over 2. Up 1 over 2, up 1 over 2, up 1 over 2. That'd be the slope. So here we are, find the slope of the line passing through each point. So I can do the first one. So we're doing y2 minus y1 over x2 minus x1. So it's 2 minus 8 over, right, so I'm doing the y's first, over 4 minus a negative 3. So notice the negatives cancel out. So we have 2 minus 6 is negative, 2 minus 8 is negative 6. 4 plus 3 is 7, so negative 6 sevenths. So make sure you put your y's together and your x's together. That's an ugly color. Ugh, how about this one? Perfect. Alright, so we put our y's together. Beautiful. Alright, so negative 5 minus a negative 5 over 6 minus 3. So 5 minus negative 5 is the same as negative 5 plus 5. 0 over 3. It's a slope of 0. Make sure you simplify. Right? Negative 6 minus 1 over 8 minus 8. Negative 6 minus 1 is negative 7 over 8 minus 8 is 0. So this is undefined. Alright, make sure you simplify. And then we have 1 minus 4 and negative 3 minus a negative 3. Let's cancel out. So we have negative 3 over 0. Once again, that's undefined. So what is this? So we have 2 more. Then we'll just talk about what undefined means. So here's my 2 points. Color code them. So negative 2 minus 2 over negative 3 minus negative 1. So negative 2 minus 2 is actually negative 4 over negative 3 minus a negative is plus 1. Negative 3 plus 1 is negative 2. The negatives cancel out and we have a plus 2 slope, positive 2 slope. So hopefully that makes sense and you can see it. We go up 2 over 1, up 2 over 1, up 2 over 1 along that line. It's a positive 2. Oh my gosh. Over here are our 2 points. So I'm just going to be plugging in to the y2 minus y1 over x2 minus x1. So it's going to be negative 1 minus 0 and 0 minus a negative 4. So that will equal, well, negative 1 minus 0 is negative 1. 4 minus a negative, same thing as adding a positive. So we have a negative 1/4 slope. Go down 1 over 4. Down 1 over 4. Cool. So in summary, lines with positive slope increase to the right. Lines with negative slope, they decrease to the right. Lines with 0 slope are flat, horizontal. And lines with undefined slopes are vertical. So let's find the rate of change to the following data sets, include proper units. Does the XY table have a consistent rate of change? Right? Does it model a linear function? So remember, linear function means it has a constant rate of change. So if we don't have a constant rate of change, it won't be a line. So here I'm going to pick these 2 points. Time is your x, distance is your y. So I have 2, 12 and 4, 24. So y2 minus y1, 24 minus 12, and then x2 minus x1. So 24 minus 12 is 12. 4 minus 2 is 2. So it simplifies to 6. Let's make sure we have a constant rate of change. So between these two, 36 minus 24 over 6 minus 4. That's 12 over 2, so it's 6. We have these 2 points. 48 minus 36 over 8 minus 6. So that's also going to be 12 over 2 or 6. And then the last 2 points, right, 8 and 10. So 60 minus 48, because remember the y's, y2 minus y1. 10 minus 8, once again, 12 over 2, which is equal to 6. So we have a constant rate of change. Another way you could see this is, well, going from 2 to 4 is 2, 2 to 4, 4 to 6 is 2, 6 to 8 is 2, 8 to 10 is 2. When we go 12 to 4, that's 2, change of 2, 24 to 16 is a change of 12, 36 to 48 is a change of 12, and 48 to 60 is a change of 12. So we have a constant x. Oops. So we have a constant change in x and change in y. So that means we're going to have a common slope. We're going to have a constant slope, so it means it's linear. Linear. Let's try this one. So I'll pick these 2 points first. So remember, here's your y. So 0 minus negative 2 over 2 minus 0. So minus a negative, same as adding, so 2 over 2 is 1. Let's do these two. So 6 minus 0 over 4 minus 2. So it's 6 over 2. Let's see. 6 over 2 is 3. Oh no, what's happening? That's not the same. Oh my gosh. Okay, well, let's try these. 16 minus 6 over 6 minus 4. Notice we're getting 2 every time on the bottom. So x has a constant rate of change. Seems like y does not. So our slope is increasing. 1, then 3, then 5. So we can say it's not linear. I don't even need to check the last one because I can see my slope's not constant. Lastly, let's try these. So 7 minus 3 over 2 minus 0. It's 4 over 2, so 2. Right here is 9 minus 7 over 3 minus 2. Let's also, oops. So that's 2 over 1, so that's a slope of 2. Let's see, 13 minus 9 over 5 minus 3. 4 over 2, it simplifies to 2. So notice our rate of change in x is not the same. So I'm adding 2, and then I'm adding 1, and then I'm adding 2, and then I'm adding 1. So it kind of makes sense that I'll be adding 4, then adding 2, then adding 4, then adding 2, because I don't have a constant rate of change in my x. However, the overall rate of change is the same, so this is linear. It's just because I didn't evenly space my x. I went 0, skipped 1, did 2, 3, skipped 4, 5, 6, so I'm not having evenly spaced. All right, so notice 2 to 3 is different than the distance between 3 and 5. Lastly, determine the rate of change for each equation. So you could change this into slope-intercept form, but that's the next lesson. So I prefer if we stick with what we just learned. So we're going to find the x-intercept, find the y-intercept, and then we'll find the slope. So the x-intercept is when y is equal to 0. So it's going to be 0 is equal to 8x minus 40. So that will be, let's see, positive 40 equals 8x. So 5 equals x. So my point will be 5, 0 is one of them. My other point will be, well, that's when x equals 0. So 6y equals negative 40. So y will be 40 divided by 6 is negative 6 and 2/3. So my other point will be 0, negative 6 and 2/3. So then we do negative 6 and 2/3 minus 0 over 0 minus 5. So that's negative 6 and 2/3 divided by negative 5. Yikes, that's kind of ugly. You could leave it like that, or I could move this into fractions. So the negatives cancel out, we see that. So 6 and 2/3 is the same as saying 20 over 3. Let's do 6 times 3 is 18 plus 2 is 20. Divide by 5. Well, multiplying by a fraction is the same as dividing by the reciprocal. Dividing by a fraction is the same as multiplying by the reciprocal. So I see that this guy is actually equal to 4/3. Nice, 4/3. The other way of doing it is I could get into slope-intercept form. 1/2 x minus 12 equals -3/8 y. I just move the y over and move the x over. So now what I can do is multiply everywhere by 8/3. Alright, so I have it in I don't have it in slope-intercept form yet. Take in mind that there's a negative, so I have -4/3 x, right? Because we crossed out the 8, put a 4, crossed out the 2, put a 1, just simplified. -4 times 1 is -4, 3 times 1 is 3, so -4/3 x. And then we have -8/3 times 12. Well, that goes to 1, that goes to a 4, so that'd be a -32 equals y. So the slope will be this, because slope-intercept form is mx plus b equals y, where m is the slope. So this is -4/3. Cool. Let me know if you have any questions. I look forward to seeing how you do on the quiz.